Right now, the Great Red Spot on Jupiter is still shrinking, and NASA has no way to stop it. This storm has raged for at least 300 years. It is bigger than Earth. Astronomers at Hubble have watched it collapse for over a decade, and they cannot explain why it refuses to stop. But here's what nobody is telling you about where this storm goes when it finally disappears. The Great Red Spot is a hurricane, not a metaphor. A real spinning storm of ammonia ice and unknown red chemicals locked in Jupiter's southern hemisphere. It spins counterclockwise, once every 4 to 6 days, with wind speeds tearing past 400 miles an hour. When astronomers first measured it in the 1800s, it stretched over 25,000 miles across, wide enough to swallow 3 Earths side by side. That's why it became the most famous storm in the solar system. Generations of scientists assumed it was permanent, a fixed feature of Jupiter like a scar that never heals. Then, starting in the 1930s, something changed. The storm began to shrink, slowly at first, then faster. By 2014, it had lost nearly half its width. Today, it barely fits one Earth inside it, and the shrinking has never reversed. Here's the part that unsettles researchers. Storms this size are supposed to be self-sustaining. Jupiter has no solid surface to create friction, no landmass to break up weather systems the way Earth's oceans and mountains do. In theory, a storm that big, spinning in that atmosphere, should persist almost indefinitely, fed by the planet's own heat and rotation. It shouldn't be losing mass year after year. But high-resolution images from the Hubble Space Telescope show the spot doing something even stranger than shrinking. It's changing shape. It used to be a wide oval. Now it's rounder, more compact, almost circular. Smaller storms nearby have been seen slamming into it, appearing to feed it, briefly refueling the system, and still the overall trend keeps going one direction: down. Some scientists have quietly started asking a question they don't like saying out loud. What if the Great Red Spot isn't just shrinking? What if it's dying? The obvious explanation would be simple. Big storms lose energy, they weaken, they vanish, the way hurricanes on Earth blow themselves out over cold water. But Jupiter doesn't have cold water to rob the storm of fuel. It has a churning atmosphere of hydrogen and helium that should keep pumping energy into the system indefinitely. Researchers at NASA's Jet Propulsion Laboratory have run models trying to reproduce the shrinking rate, and the numbers keep coming back wrong. The storm should be more stable than this. It should be losing mass at a fraction of the observed rate, not barreling toward a smaller, tighter, more violent version of itself. Nobody at NASA will commit to a timeline, and that silence is its own kind of answer. This is where it gets disturbing. As the Great Red Spot shrinks, it isn't just getting smaller, it's getting angrier. Wind speeds inside the compacted core have been clocked increasing, not decreasing, even as the storm's total size drops. Imagine a figure skater pulling their arms in and spinning faster. That's what's happening to a storm wider than our entire planet. Some researchers now believe the spot isn't fading out quietly at all. It may be collapsing inward into something smaller, denser, and far more violent. A compressed version of itself with wind speeds that could eventually rival anything ever recorded in the solar system. And here's the detail that keeps coming up in Jupiter research circles but rarely makes headlines. Smaller storms don't just disappear on Jupiter. They get absorbed, or they persist as small, furious red survivors, spinning indefinitely in a planet with no friction to ever slow them down. If the Great Red Spot follows that pattern, it doesn't vanish. It becomes something smaller, tighter, and possibly more dangerous, locked into an atmosphere that never lets storms die. A 300-year-old hurricane bigger than Earth, potentially about to become a smaller storm humanity has never had to reckon with before, still spinning, still unaccounted for right now. If that's true, everything textbooks say about Jupiter's most famous feature needs rewriting. We've treated the Great Red Spot like a landmark, a fixed identity of the planet, something you could point a telescope at and always find in the same place, doing the same thing. But if a storm this massive can fundamentally transform instead of simply fading, it means we don't actually understand how giant planet atmospheres behave over long timescales. And it isn't just about Jupiter. Astronomers are now finding storm systems on other gas giants, other exoplanets entirely, using the same assumptions this one just broke. If those assumptions are wrong here, they're wrong everywhere we've applied them across the solar system and beyond. Every model of Jupiter's future, every prediction about how this storm behaves next, is now built on watching something scientists admit they can't fully explain in real time with no way to intervene. So the Great Red Spot is still shrinking right now, this hour as you watch this. Nobody at NASA can tell you when it stops or what it turns into when it does. What do you think happens when a 300-year-old storm finally runs out of room to shrink? Tell us below.